Hello, grade 10s, and welcome to the second segment of atomic mass and the mole. Right now, we're going to be dealing with molecules, right? We're going to be dealing with compounds, so it's no longer just atoms. Okay, please take that down. I also modified it from siavola.com. So number one asks, what do we call the mass of 1 mole of a chemical substance? The mass of 1 mole of a chemical substance is called the molar mass. In tertiary chemistry, it is called the molarity, right? But just call it molar mass. Number 2 states, calculate the number of particles in the following samples. 2.1, 65,25 grams of barium nitrate. So we have a compound by the name of barium nitrate. So barium is in group 2, so it's going to be Ba2 plus. Nitrate is an ion, okay, so it's NO3 minus. This one comes here, this 2 comes here. So barium nitrate is, okay, this is the formula for barium nitrate. Thank you. So now we are given the mass, which is 65,25 grams again. Now we need to calculate the molar mass. So the molar mass of barium nitrate is the molar mass of barium, right, plus nitrogen is 1 times 2. So 2 times the molar mass of nitrogen plus oxygen is 3 times 2, which is 6. 6 times the molar mass of oxygen. Okay, so it is going to be, what is the molar mass of barium? The molar mass of barium is 137 plus 2. Molar mass of nitrogen is 14 plus 6. Molar mass of oxygen is 16. Then you use the bond mass rule. 137 plus 2 times 14 is 28 plus 6 times 16 96. So it's 137 plus 28 plus 96. I'm getting 261 grams per mole. So formula, number of moles is equal to mass over molar mass, which is 65,25 over molar mass, which is 261. I'm getting 0,25 moles. Now when it comes to the number of particles, right, we have another formula which is N is equal to number of particles over Avogadro's number. N is 0,25. We don't have the number of particles. Avogadro's number is 6,02 times 10 to the 23 particles. Right? So N, number of particles, is 0,25 times 6,02 times 10 to the 23. Right? So I'm going to write it here. Okay, let's write that. It's 1,505 times 10 to the 23. To do decimal places, it's 1,51 times 10 to the power 23 particles. So number 2.2, we have 1,537 kilograms of potassium phosphate. So once more, potassium is in group 1, it's just K plus. Phosphate, it's PO4 3 minus. So this 3 comes here, this one comes here, so it's just K3 PO4. So this is the formula for potassium phosphate, K3 PO4. So the molar mass of K3 PO4, so it is 3 times the molar mass of potassium plus molar mass of phosphorus plus 4 times the molar mass of oxygen. So 3, what is the molar mass of potassium? 39 plus molar mass of phosphorus is 31 plus 4 times the molar mass of oxygen is 16. Three times 39, 117 plus 31 plus 4 times 16, 64. So the molar mass of potassium phosphate is 117 plus 31 plus 64. It's 212 grams per mole. Okay, mass is 1,537 kilograms, which is 1,537 times 10 to the power 3 grams. $1,537. Okay, so number of moles is mass over molar mass. 1,537 over 212. 7.25 moles, right? Then once again the number of moles is equal to number of particles over Avogadro's number. So it's going to be 7.25 is equal to number of particles over Avogadro's number, which is 6.02 times 10 to the power 23. So n is 7.25 times 6.02 times 10 to the power 23. I'm getting 4.3645. Therefore, the number of particles is 4.36 times 10 to the power of 24 particles. I hope that makes sense. 2.3, 87 grams of magnesium hydroxide. Okay, once again, magnesium is second group, Mg2 plus. Hydroxide ion is OH minus. This 2 goes here, this 1 goes here. So the formula for magnesium hydroxide is MgOH2. I hope it makes sense. Right? So the molar mass of magnesium hydroxide is the molar mass of magnesium plus 2 times the molar mass of oxygen plus 2 times the molar mass of hydrogen. What is the molar mass of magnesium? 24 plus 2. Molar mass of oxygen is 16 plus 2. Molar mass of hydrogen is 1. So it's 24 plus 2 times 16 is 32 plus 2 times 1 is 2. 24 plus 32 plus 2 is 58 grams per mole. Mass is 87 grams. So the number of moles is equal to mass over molar mass. 87 over 58 1.5 mole. Okay, now the number of moles is equal to number of particles over Avogadro's number. So 1.5 is equal to number of particles over Avogadro's number, which is 6.02 times 10 to the power of 23. So n is 1.5 times 6.02 times 10 to the power of 23. So I'm getting 9.03 times 10 to the power of 23 particles. Okay, I hope that makes sense. Number 3 states, calculate the mass of a sample of silicon dioxide with 9.6325 times 10 to the power of 23 molecules. So silicon dioxide is a molecule, right? And the formula is in the name. Silicon is Si, dioxide is O2. Okay, so the molar mass of silicon dioxide is the molar mass of silicon plus 2 times the molar mass of oxygen. The molar mass of silicon is 28 plus 2 times the molar mass of oxygen, 16. 2 times 16 is 32. 60 grams per mole. Hope that makes sense. Now we're calculating the mass, right? We have the number of particles. Okay, so it's going to be number of moles is number of particles over Avogadro's number. Okay, number of particles is 9,6352 times 10 to the power 23 over Avogadro's number, which is 6,02 times 10 to the power 23. These cancel each other out, so you have 9,63 52 divided by 6,02, and I'm getting 1,6005. Okay, sorry, 6005, just like that, right? Moles. Now we go back to the original formula. Number of moles is mass over molar mass. So 1,6005 is equal to mass over molar mass is 60. So mass is 60 times 1,6005 times 60. I'm getting 96, 0318, 9368, 7708. Okay, so the mass is 96,03 grams. 2 decimal places. I know that was a bit too challenging, especially the last part. Please forgive me. Okay, if you found this helpful in any way, please click the like button and subscribe for more content. The next one will definitely be modified from past papers. Thank you very much.